Hello there. Once again, time for a small progress update. What am I got going here? Nothing. Now, as for our story continues, we're looking at this PC view, and I've actually managed to set up the threading bit. I should use his name. Use the word window here, unfortunately. Now this is supposed to be this mode 13. Where is mode 13 go? .h. Oh, here it is. Now, what is this mode 13? I made a mistake. I apologize. Last time I said int 13. It's not int 13. It's mode 13. You know how hard I've tried to. You see these two icons? They look exactly the same. I want to change one. I changed the icon for Google Chrome. It's already gone back. It's already gone back to the original. Anyway, int 10. Set video mode to 13. Alright. Now it's hard to read this table because it's not formatted correctly for some reason. But I've written it down in here in one of my header files. Okay, so node 13 is either according to this table thing, it can be either is it a text mode or is it a graphic mode? And it's a graphic mode. Now it still has an entry for text resolution, so I suppose you can do text, with a system supplied font in this mode, and in that mode, it's 40 characters wide and 25 characters high, unlike this thing, which is 80 characters. This is 80 by 25, so that's half the number of characters. Pixels per box must refer to one character's pixel dimensions, so 8 pixels by 8 pixels is one character, and this is the pixel resolution of the display. So after you switched into this mode, you would have started out in this mode, which would have had a lower pixel resolution, even though I could do more characters, I think. I think it was 80 by 25. It must have been. Now, so that's 320 by 200 pixels, okay? Now, this is what they call VGA. You'll notice here, it's also listed that this is called VGA, which was introduced around that time and was called Video Graphics Array. Okay, so these are for the new high-res monitors that were coming out with all kinds of colors and everything. You could get it up to 320 by 200. That's about this big on this screen. Now colors, now it's a paletted mode. It's 13 mode. So there are 256 palette entries, and it says it's 256,000 kilobytes. Tried to work that out here. If you have 320 by 200, okay, and you can calculate that out. That's how many pixels there are. Almost 64K. No, this K is not the right K. It turns out if you multiply that by 4, you get 256,000. So that would indicate 4 bytes per pixel. These number of pages is blank. Screen address. Now this is where the video memory is stored. And this is all related to that DOS 64K limit. Okay. Video memory. There. This is an insert to this video. I did a calculation there. 320 by 200, 64K-ish. And according to that, this table here, we have 256K worth of video RAM available, at least space-wise, in this mode. Now, it's true that if I multiply this by 4, I get 256K something. But remember, this is DOS, okay? So everything is in 64K chunks. So the question is, what does this mean? It can't mean, it certainly can't mean 4 bytes per pixel. And that's where this complicated business comes in, which I'm still trying to make sense of. Now you see, the 256K is not directly available. Everything is accessed through 64 kilobyte windows in the real mode address space. The video RAM is actually a bank of 4 planes. Now that may be where that BI planes thing comes from in a bitmap info header. Each 64K. Now remember, this is still a paletted mode. Now, the programmer can decide how some or all of these 4 planes will be affected by each read or write operation. In 256 color mode, each byte in a plane represents a pixel. On the first line of the screen, if you take them in 4s, it goes like that. These are all in memory plane 0. Okay, so 64K worth of those. And then another set, and so on. So 1 byte into one of these windows, when all the planes are enabled, will write 4 bytes of the same value at once. So they're taking the they're taking their little window, 64K byte window, and using the different planes to map to different pixels in this on the screen. Now, I don't see how this is an advantage, except for the fact that you might be able to use 4 different palettes. And so I'm not really sure, and this is something I gotta look more closely at, and this particular article is not very well written. It even says it's confusing and unclear, and I agree, it is confusing and it is unclear, and I'm trying to find out exactly what's going on. But I don't think our friend here is using any like super duper super duper fancy stuff. Okay, 13 palette data, red, green, blue, palette mask, specified index, color 1, 2, 3. That's just red, green, blue. Hopefully we won't have to deal with 4 palettes. But if that's the case, that's the case. It all translates easy enough, to a full true color device context. We just got to figure out how to extract the right color for the right position. Okay, that's just a small insert I wanted to add. It's reserved by the processor to begin at segment A000 and go all the way through the A's and the B's, and I think they call that the upper memory area. Let's see if that's true. Yeah, that looks right. So we get a conventional memory up to 64K, then upper memory, right, from A000 onwards was upper memory. So anything after that was sort of unusable. Although, I don't know about C. See, like B7, B800 is regular text, by the way. See? Dump B800 0. It's going to say Microsoft Windows version 6.1 blah blah blah. Microsoft Windows version 6.1 blah blah blah. That's where color text mode memory was stored. Okay, still would be. A B000 would be for a monochrome. I happen to have a monochrome monitor, which had a special expansion card for it. So I had memory all the way from B000, B000, all the way up to through all the B's. And then A is before the B's, and that's for like high resolution video, like 320 by 200. It's quite high. Now then, eventually they came out with SVGA, which was like super advanced, super high resolution. super video graphics array, okay? So that meant you could do like 640 by 480 display. Really high resolution. Well, you could do 800 by 600. Okay, so even better. 640 by 480. Alright. Now, aside from all the naming and everything, yeah, that's where's my other thought? It turns out that A area, of course, see it in these boxes. This is all virtualized. What was I? Look at that. Oh, I know why. How about if I debug dump B800 0? Okay, now it should be mostly empty, as it is. It's empty because I just cleared the screen. Now I have this batch file that copies from the B segment to the A segment from my print screen. So it works this way. PS, now 2 is the number of pages I want to copy. Page is 25 lines. Starting offset 0, that's the upper left corner. And now where do I want to put it, relatively speaking, in the A's? I can just say 0. So now, if I go into, now see all these characters? Those are all going to be at A800 0. See? There they all are. I just copied them there. If I wanted to restore that, like I have a thing to restore, this just reverses the A's and the B's. 2 pages worth starting at 0 and destination 0. Now let's see. It looks like my cursor is here, but in fact it's up here. See? That's where I am. Now, SVGA was a different mode completely. So, like, games were written in SVGA modes, like the 320 by 200, and that, of course, started in the A's that I've been using just for my own benefit. So, what I wanted to do was invent a window, which I have. Here's the window. It's supposed to represent the mode 13 window, so it should be 300 by 320 by 200 size. Okay. Now I'm drawing it up here in the corner here, and then just running an update loop. Now, in order to try to slow things down with the different threads, I create the thread with the message loop, but then I create one of these waitable objects just so that we can slow things down. Otherwise, it's instant, and then I can wait for that object to become signal. It's no use going through a loop and looking at some Boolean or something, then the system will crash. These waitable objects are thread safe. Okay, so I'm okay to wait on this, even though it's a global variable. So now it starts off in the unset state, turns out, but this is a macro. It's fine somewhere, trust me. So now I'm waiting for this object to become signal, or it could time out, but this is going to wait forever, so it'll have to get signal. And what I've done here is in my window, on my uncreate, I set a timer, okay, and so that now the timer's identifier number is a pointer to that handle, that object, okay. Now I don't kill the timer, but it shouldn't matter. I'll keep setting that event, but who cares? When the timer gets hit, I set the event, and that should release this guy from his wait to the other thread. Okay, and that'll bring us back to this line. So we start the window, we wait. 10 seconds later, that thing gets signaled, and we should end up here. And then we go back to catch. Now, back in our... Okay, so now the window will be running at that point. So let's just get it going to there. Now I can step through this slowly. Oh, press any key to begin. See? So now we're just at a regular old catch. And I'm going to stop here. Okay, I'm going here. I've got to make sure that well, it's 10 seconds pretty long, so we might have to start over again. But anyway, now eventually, there should be two threads here, in here. Thread. Create running. Now the thread hasn't started yet, but when I start on this wait here, there's the window. Okay, now we got two threads here. Alright. Now one of them is going through a message loop, and the other one is waiting for this thing to get signal. And it should wait for 10 seconds. Okay, so I'm going to keep running. Run, exactly. Okay, now the wait finished. Notice how I can't show these windows. I can show this. No, that's nothing to do with anything. I can show this window, but I can't really show this window because there's a secret system thread running this window, and I don't know what it is, but it's not listed there, but it's doing something. All right, F5. Now we're back to Getch. So we did that part. Press any key to end mode 13. Okay, so now it's going to go to this uninit, which I've also put in a fake wait. So if I press a key, the window should be there now, visible. Where is it? The program's running. I'm not stuck, am I? Oh, I see. That was something to do with WM Paint. It's there anyway. Okay, there's a window there. Okay, now that window is still there. For some reason, it won't repaint itself, or it won't come back to life. See, I've killed it. It doesn't. I've killed it because of the way I've set it up. I've done something in WM Paint. Probably doing something bad. I posted a WM clip. Yeah, I never stopped. I should kill this timer. Kill time. Okay, it's stopping. First it starts out with this fall. Kill timer. That's what's happening. And W prime, I guess, is the ID. But once I start it up again, yeah. I think we should be okay now. It won't go away on us. Sorry for the 10 seconds. Oh, start, yes. Okay, now this is a fake wait. It's obviously out running and everything. Okay, now it shouldn't die on us. That timer is dead. Now, if I want to end the thing, I call uninit. So I press a key, go to uninit. Now I locate the window handle, which is still there, thank God. And now I post a WM close to that window. Now WM close, if B stopping, which I have set to equal to true, if that's true, it's going to reset that event again and set the timer for another 10 seconds. And when it gets the timer message, again, B stopping equal to true, then it's going to post an actual WM close message and set this to false, so that when this comes in, this will be false and it'll close. So then, it's again a fake wait. So I post the close message and then I'm waiting again. But this time I'm not actually waiting on that object. You can also just wait on this thread ID, the thread handle as well. This thing that's returned from begin thread is a waitable handle. So, I could wait on either object, but just to show you that both work, I can wait, and this is the same as waiting for the thread to terminate. So I press F5. Okay, the window should still be there. It's our super high resolution graphic. Okay, now it died. Press any key to exit. So okay, now we got multiple threads, waitable objects, and what we want to do is draw on that little window. Now, the way this thing works is by direct drawing. That is, it switches modes, and it assumes that you can go and start drawing. Draw a line, draw a pixel, and so on. However, I'm pretty sure that we're not going to be able to draw, even if we made a memory device context, right, which would be a shared resource, and we would have to synchronize it. Writing to it wouldn't. I don't think it'll work. All the writing, all the updating of the screen and everything should happen in the thread that owns the window, because that's where those GDI objects will be created. But that's fine, because we don't want to do it in our thread anyway. If we want to draw this box, okay, this is a function, right? What we would like to do is tell the window to do this, to perform this action. And so that means we want to create a customized Windows message that contains within it, so let's say perhaps an object that has a virtual function of some sort, okay, that tells it what to do. And then the window will receive that message in its own thread, and then carry out the drawing operation. And now that method of taking the operations that we want to do in one thread, in the pick view thread, we want to do those drawing operations, right? Like show picks and go to X, Y, and all that stuff we want to do in this thread is done by posting those messages to the window that will actually do it, and that process is called marshalling. Okay, so basically everything gets thrown into a queue, and they're dequeued, the messages and the procedures, in a different thread and executed in the same thread. And so it's like everything marching in a line, so it's called marshalling. So I'll develop a marshalling procedure so that we can just call these functions as we normally would, and have them get executed in the correct thread, in the correct context, and written to probably a memory device context. So if we draw a box, right, it'll get drawn into a memory device context in the other thread, and when the window needs to draw itself, all it will do is a bit blip from a memory DC to its window. And so that way, drawing text and stuff is easy. We don't have to remember what's there, everything will be stored in a memory DC. So that's the plan from this point on. I'll try and make it work. See ya.